Okay guys, this is both a 5th and a 6th grade standard. So today, you are 5th grade, you're working on standard 5G, 3 and 4 again. For 5th grade, it is lesson 815. For 6th grade, this is activity 22, lesson 1. I apologize, 6th grade, I don't have the standard with me right now, and I don't want to look it up because I've been super busy today. So go with it. All right, title today is Properties of Triangles, Sides, and Lengths. And we are going to define the triangle inequality property, okay? So what this triangle inequality property means is for any triangle, the sum of any two sides must be greater than the length of the third side. Okay, so we'll talk more about this as we go. The other thing that I'm going to add here, and I'm not sure if it's probably in the lessons to come, but the more often I repeat it, the better it is for you. So the other thing about triangles, the awesomeness of triangles, angles of, see, I'm talking about sides and lengths today, but it doesn't hurt for you to know this. So the angles of triangles are special as well. All 3 angle measurements of the triangle will equal 180 degrees, okay?
3, 4, 5.
Shush, please. Count in your head. Okay, so those are 2 major things that you guys have to know when you're talking about triangles. So we are going to go ahead and get a half piece of computer paper. I'm going to remove the book for just a moment. You can pause the video. I'm just going to keep going. And you're going to fold this into thirds, the best of your ability, just like we do in class. All right, so we have a trifold booklet, okay? And we are going to name this, I guess I'll use this color, so I don't really have a red. I'd prefer, oh, I do have red. My kids always take these out of here. Ew, it's like orange. Oh, well, whatever. So we are doing triangles today. Gotta love crayon. A crayon that I don't really like the color of, but whatever. I'll get over it at some point in time. Triangles. All right, so in the first flap of our booklet, go ahead and open it up. So over here on the left side, let's see if I have some blank paper I can utilize here. Adriana's work, no. I'm going to put it on this because I hate writing on just a flat surface table. Okay, so on your first flap right here, the sum, oh look, it's right there. That's hilarious, but I'll give you an example with it. So the sum of all angles equals 180 degrees. Okay, so let's go ahead and draw a triangle in here. Just a beautiful triangle. Okay, all right, so we've got a triangle here, and we are going to label this angle right here 53 degrees. We're going to label this angle right here 42 degrees. We're going to label this angle right here an unknown, so it's a variable. So the way that we find the unknown angle, if this angle plus this angle all equal up to 180 degrees, then simply I would add these two first. I find that to be easiest. So 53 plus 42, and that equals 595. And this is all degrees, okay, when you measure them with a protractor. Then I'm going to take the total, which is 180. I'm going to subtract out 95, and that's going to give me 85 degrees. Okay, so your formula up here would have been 53, I'm going a little backwards, plus 42 degrees, plus your third angle of x equals 180. Simple enough, right? Okay, the middle one, we are going to talk about isosceles triangles. So we're going to go ahead and open this up. And in the middle here, we're going to label it isosceles. Triangles, okay? And this time we have to actually try and make it look isosceles. So I am going to measure this side of my triangle 2.5 centimeters. This, I should have made it a little bit bigger than that. It's going to look a little bit lopsided to you. 2.5 centimeters. And then I'm going to make my bottom here like this. Okay. So an isosceles triangle. Let's actually down here, let's define acute. I know I did in a couple videos ago, but an acute angle is any angle whose measure is greater than 0 degrees, but less than 90 degrees. So essentially, it's 0.1 or even smaller than that, all the way up to 89.9. Okay? Obtuse. Obtuse angles are greater than 90, less than 180 degrees. Okay? So a really quick lesson on angles, since we haven't talked about those yet. Up here, back on my triangle, we have two sides that are equal length. So we're going to put our tick marks to show that this side and this side are equal length. The one on the bottom is not equal, so we're going to have 2 tick marks there to show that. So the way you know this is an isosceles triangle, isosceles triangles have two sides of equal length. All right. Now there's 2 ways to classify this. So it's not just isosceles. You have to look at the angle in between the 2 sides that are the same length. So we are looking at the angle right here, and we are going to classify this as less than 90 degrees. Remember, a 90 degree would be like right here. It would be like this, right? This angle right here is different than this angle and this angle, which are the same. Okay? This angle right here is acute, which makes this, actually, if you look here, this is also acute as well as this one. So this is an acute isosceles triangle. So you have not just one classifications, you have 2 classifications. Now on this next one, be sure to draw it somewhat like I am. So we're gonna draw one straight line here. I'm gonna make it 2.5 centimeters again. Then I'm going to make a 90-degree angle here. And it's going to be 2.5 centimeters again. And then you're going to connect those lines. And notice that this last line is longer than those first two. So let's label our lines with tick marks. Those are different. We are going to label this 90-degree angle with a square so that everybody knows that that is 90 degrees. And then our last section right here, we're going to label with 2 tick marks because this angle and this angle are the same measurement, but this line is different than these 2 lines. Okay? So again, we need 2 classifications. We can classify this if it has any of the 3 angles are right angles. The first classification is right. And the second classification, if you have 2 equal sides, only 2 equal sides, it is isosceles. So this is a right isosceles triangle. This is an acute isosceles triangle. And now our last one, we're going to do an obtuse. So I'm going to stick with my lovely 2.5 centimeters. I think it's working pretty well for me. And I need to make this angle obtuse. So I'm going to do it like this. And then I'm going to connect those lines. Wow, this is really large. Okay, so again, this side length and this side length are equal. This one is not equal. This one right here is obtuse. I'm going to label it with 2 marks. This one right here is the same as this one, but they are acute. So if any of these 3 angles are obtuse, then this first classification is obtuse. And the second classification is isosceles. Okay? 2 classifications for every single triangle. Okay? On the last section down here, oh, no wonder why I should have started with this side. Ha, that's funny. Types of triangles. That's funny. Not really. All right, so our first type of triangle is scalene. ... A scalene triangle has no angles nor sides are equal. Okay, and we will draw an example for it. This one doesn't have to be perfect, but remember that all sides have to be obviously different lengths, okay? Now we are going to label it. So side 1 is different than side 2, which is also different than side 3. Not just that, but your angles also follow the same rule. If none of your sides are the same, none of your measurements of your angles are the same. Okay. The next one is isosceles. Okay, an isosceles triangle, ... has 2 congruent sides. That means congruent or equal to sides. And it also has 2 congruent angles. Okay, and I will just draw another example here because why not? Okay, this side is equal to this side, but not equal to this side. This angle is not equal to this angle, but these 2 right here are equal. Okay, and last one is called an equilateral. Triangle. I'm going to add something on this. I'm super excited. Okay, so it's an equilateral triangle, meaning that all angles are equal. All sides are equal. I'm going to draw an itty bitty one right here. to the best of my ability. Hopefully it looks perfect, even though it won't be perfect. Pretty darn close. So this side is equal to this side is equal to this side. This angle is equal to this angle is equal to this angle. Equilateral. So when you go to classify a triangle, you have to have one of these three: scalene, isosceles, equilateral. Okay? Now fold this door in, our last page right here. If I can get the cap off this pen. All right, so on this page, we are going to talk about the second classification. Angles, angle classification. So here's the thing. You can classify a triangle upon its angles. I should make that one a little bit longer. Otherwise it's going to look like it's right. I don't want to write one. Okay. So the first question to ask yourself, questions. 1, is there a right angle? You will know this because it will have that little square label, okay? Like in here, this square will label the right angle. If it has a right angle, if yes, it is a right angle. It is a right isosceles, a right scalene, or a right